In this video, we look at confidence intervals for proportions, again in Chapter 7 of your statistics textbook. So again, the idea is we're trying to estimate the value of a proportion, some population proportion. So we'll use our sample proportion p hat. And like we did with means, we'll center the interval around the proportion p hat. And then we go a little bit above and a little bit below in an attempt to account for variability and our confidence level. So this E is going to depend on your sample size, it'll depend on the variability in your proportion and your sampling process, and the confidence level chosen. So here's the formula. So similar to the means, we centered around p hat, and then we have this plus or minus. So we'll add this amount and subtract this amount to create an interval that we can be confident that the true proportion falls in. And notice the z value is the same as we had before. These are the critical values from the standard normal table, and these are the values that cut off the middle percent depending on what confidence level we're looking at. P hat is your sample proportion, N is your sample size. So this is often referred to as a large sample confidence interval for a proportion. And the general rule for large sample is N P hat and Q hat both bigger than 5. Basically what that means is you want to take a large enough sample so that you get responses from both categories depending on what you're looking for. So if we look at an example, suppose we take a survey of 30 students in a statistics class and 14 of them were business or accounting majors. If we wanted to construct a 99% confidence interval then for the percentage or proportion of students who are business majors, business or accounting. So we'd use our formula, p hat plus or minus z times p hat 1 minus p hat over n. Plug in our values. Our p hat, our sample, 14 out of the 30 people we sampled were business or accounting majors. 2.58 is the value for 99% confidence from the standard normal table. And then we have p hat, 1 minus p hat over n. So we get 0.467 plus or minus 235. So I add 235 to get my upper limit, subtract 235 to get my lower limit, and so a 99% confidence interval is 0.232 to 0.702. Now if you think about that, this is a very wide confidence interval. It really doesn't tell us a whole lot of information. I mean, we're 99% sure that the proportion is somewhere between 23 and 70%. That's a very wide range. It's not very precise, and therefore it's really hard to draw any definite conclusions from this. So oftentimes in statistics, we figure out what sample size is needed to get a smaller or narrower confidence interval or a more precise confidence interval. So like with means, this is often referred to as sample size determination. So if we take this same example, suppose I wanted that margin of error to be no more than plus or minus 5%. The previous one, it was about plus or minus 23%, way too much. So there are two formulas for this. N is p times 1 minus p times this z squared over e squared, or 1/4 times z squared over e squared. And the difference is whether or not you have an idea of what p is. Because remember, p, the proportion, this is what we're trying to estimate. So if you have some sort of preliminary estimate of what it is, you can use that. From previous data, previous sample, or a lot of times in statistics we take a pre-sample to get an estimate of that then we can use to determine the sample size. If you don't have an estimate, you just simply plug in a half, and that's where that 1/4 comes from. A half times a half is 1/4. So in our example, we were looking for 99% confidence and E of 0.05. Our p hat from the previous example is 0.467, so we've got an idea of what p is. So we will use that and plug it into that first formula. P times 1 minus p times z squared over e squared. If we plug all that in, we get 662.74. Of course, we always round up to the next whole number. So I would need a sample of 663 or more to get the width of that confidence interval all the way down to plus or minus 0.05. But this is very important in statistics, particularly polls. If you look at polls, oftentimes they note the margin of error, and it'll say plus or minus 2% or plus or minus 5%. And what they've done is they've set up their sample, they've figured out a sample size needed to get that degree of precision. Because a smaller interval is more precise and it allows you to make more definitive conclusions.